Alrighty, happy Thursday. So if you remember back to middle school, you learned about the Pythagorean theorem. The Pythagorean theorem is used with right triangles. The Pythagorean theorem in standard form is a squared plus b squared equals c squared, where a and b are called legs of the right triangle, and c is the hypotenuse. Okay. We know that C is also the longest side of the right triangle. Okay. So if C represents the length of the hypotenuse of a right triangle and A and B represent the lengths of the legs, solve for the length of the missing side. So we're just going to set this up. I know what A is. So A squared plus B squared equals C squared. A is 6, so 6 squared plus b squared, 8 squared equals c squared. 6 squared is 36, 8 squared is 64 equals c squared. Well, 36 plus 64 is 100 equals c squared. I have to find out what c is. The only way that I can get c to be by itself unsquared is to take the square root of it. So square rooting something unsquares it. So what number do I multiply together to get 100? Well, it's 10. 10 equals C. Also, I could think of it as negative 10, right? Excuse me, negative 10 multiplied by itself equals 100. However, we're talking about measurements of an actual object, and I don't think that anything can have a negative measure if it's an actual object, right? Like the side length or the hypotenuse of a triangle cannot be negative. For example, B, a squared, 5, plus, I don't have a B here, b squared equals c squared, 13 squared. So let's see, 5 squared, that's 25, plus b squared equals 169. When I subtract 25 from both sides, I find out that b squared equals 144. Take the square root of both sides, and I find out that b equals 12. All right, example C. I don't have an A squared plus 4 squared equals 5 squared. A squared plus 16 equals 25. When I subtract 16 from both sides, I have that a squared equals 9. When I take the square root of both sides, I find out that a equals 3. So that's how you use the Pythagorean theorem to find the missing side of a right triangle. If you know two of the measures, you can always find out the third, okay? So for those first three examples are what we call Pythagorean triples. Let me make a note of that somewhere. So the first three letters A, B, and C are called Pythagorean triples. All that means is that they're three integers that work for the Pythagorean theorem. Most often, your Pythagorean theorem produces a decimal. So let's look at this one. A squared, 6 squared, plus b squared, 4 squared equals c squared. Well, let's see, 6 squared is 36, 4 squared is 16 equals c squared. 36 plus 16 is 52. 52 equals c squared. Well, I have to take the square root of both sides. So in your calculator, the square root button. So square root of 52. And we're rounding our answer to the nearest hundredth. That means I need 2 decimal places to the right. So C is about, that means that I'm rounding, 7.21. Let's try it again. A squared, which is 9, So 9 squared plus b squared equals 18 squared. 9 squared is 81 plus b squared equals, I think that's 324. I need to check that. 18 squared. Yes, okay. So I subtract 81 from both sides. So b squared equals 243. When I take the square root of 243, I find out that b is about 2 decimal places. So it's 15.588. So if I'm rounding to the nearest hundredth, I'm going to say that my final answer is 15 point. This is the hundredths place. This number tells me to round it up. So b is about 15.59. In the diagram below, we're finding the value of x. So for this activity, I always just have kids label the hypotenuse. So remember, the hypotenuse is directly across the right angle. So if you know what the hypotenuse is, then the other two sides are A and B, and it doesn't matter how you label the legs, just one needs to be A and one needs to be B. I'm just going to plug these values in. A squared, 5 squared, plus B squared, 12 squared, equals C squared. That gives me 25 plus 144 equals C squared. Well, that's 169 equals C squared. And we did something similar to this, kind of in reverse up top in one of our examples. 13 is C. In example B, I don't know what B is, the side B. So I have A squared, which is 8, plus B squared equals C squared, 10 squared. 64 plus B squared equals 100. When I subtract 64 from both sides, I find out that B squared equals 36. I then take the square root of both sides, and B is 6. So these examples A and B are also Pythagorean triples. Look at that. A Pythagorean triple is any set of whole numbers, A, B, and C, that satisfies the equation A squared plus B squared equals C squared. All right. So determine if the following are Pythagorean triples. Justify your response. Well, remember that the longest side is always C. So we're just going to plug this in. 7 squared plus 8 squared equals C squared. Whoops, sorry, C is 9. And we're going to see if it's true. Let's see. 7 squared is 49. 8 squared is 64. And 9 squared is 81. So does 49 plus 64 equal 81? No, it does not, because 113 does not equal 81. So this is not a Pythag triple. That's how I abbreviate that. Let's try the next one. 12 squared plus 35 squared equals 37 squared. 144 plus 1,225 equals 1,369. I'm going to add these together. 1,369 does in fact equal 1,369. So yes, this is a Pythag triple. Okay. We often, especially in algebra 2, we use Pythagorean theorem to solve word problems. So a baseball diamond, so I'm going to draw a baseball diamond as best as I can, has the shape of a square, right? Measuring 90 feet. So these are all 90-degree angles, the bases. Each side is 90 feet, meaning the bases are 90 feet apart. We need to figure out how far it is from home to second base. So we're going from home plate to second base. Well, that's a right triangle. And that measure right there that I'm looking for is C. So I have 90 squared plus 90 squared equals C squared. Well, 9 squared is 81, so I'm just going to add 2 zeros to that. 9 squared is 81, add 2 zeros to that, right? Because 10 is 100, right? 10 squared is 100, equals c squared. Well, 81 plus 81 is 162. Add your two zeros. Take the square root of that. So the square root of 16200 is, C is about 127 point, are we rounding to the nearest tenth? So my answer is 27, so that's going to be rounded to 127.3 feet. 127.3 feet. Next one. So the length of the side of an equilateral triangle is 10. So let's talk about what an equilateral triangle is. Equilateral means that all three sides are the same. So we want to find the altitude or the height of the equilateral triangle. Well, there's a couple of things that you need to know. If you have an equilateral triangle, the height divides the side that it intersects directly in half. So we're just really going to look at this piece right here. So this is my C, this is my A, and we're going to call our altitude B. So 5 squared plus B squared equals 10 squared. 25 plus B squared equals 100. I'm going to subtract 25 from both sides. So B squared equals 75. And we have to take the square root of both sides. So I want to talk about the square root of 75 in terms of a simplified radical. And then I'll talk about it as a decimal. Well, square roots are very unique in the way that they can be multiplied together. So 75 is the same thing as 25 times 3. But 25 is what we call a perfect square. The square root of 25 is 5. So my answer is 5 root 3. If I turned that into a decimal, the square root of 75 is about 8.66. Okay. Carlos walks to school from his house by going directly east. So if this is my house, right, I'm going to go directly east for a total of 5 miles. And then I'm going to go directly north for a total of 3 miles. And then again, east for a total of 3 miles. So I need to find the shortest distance between Carlos' house and his school. That's very interesting. Okay, so let's talk about what we know. We know that that the total distance he traveled east is 8 miles, and the total distance that he traveled north is 3 miles. So I want you to think of it like this, because my picture maybe didn't do it justice. So I have 8 squared plus 3 squared equals c squared. 64 plus 9 equals c squared. 64 plus 9 is 73 equals c squared. So if I take the square root of 73 to the nearest tenth of a mile, I find out that he could have only traveled about 8.5 miles if he traveled down this path versus the 8 east plus 3 north, which is 11. Okay, so he would have saved himself almost 3 full miles. All right, so now let's talk about the converse of the Pythagorean theorem. The converse of the Pythagorean theorem lets us prove that something is a right triangle. Okay, so we use the converse to prove that something is a right triangle. Remember that the hypotenuse is always the longest side. So we're trying to use the Pythagorean theorem, 10 squared plus 24 squared equals 26 squared. And if this works, then this is a right triangle. Okay, so let's check. 10 squared is 100. 24 squared is 576. And 26 squared is 676. So 100 plus 576 is 676. So these are in fact equal to each other. So this is a right triangle. We can't make a judgment based off of what it looks like. There's no such thing as it looks like it, right? So the largest side, remember, is C, 8 squared. So I have 4 squared plus 6 squared equals 8 squared. Well, 4 squared is 16 plus 36 equals 64. 16 and 36 is 52, and 52 does not equal 64. So this is not a right triangle. Notice that the side length substituted in for the hypotenuse must be the largest. I know I said that. Okay. So we are going to determine if these numbers could represent the side lengths of a right triangle. Again, I'm going to identify the largest sides. We're going to talk about that for a second. So let's see, 9 squared plus 12 squared equals 15 squared. 81 plus 144 equals 225. That works. All right, so we need to figure out which is bigger. 2 times the square root of 5, 2 times the square root of 5, or the number 6. So the number 6 is the larger number here. But what about, well, you know 4 is bigger than the square root of 3, but anyway. So let's see. 4 squared plus, I'm going to put this in a parenthesis, 2 root 5 squared equals 6 squared. So I know 4 squared is 16. I'm going to break this up. Let's see. 2 squared is 2 times 2, or 4. And the square root of 5 squared is 5. So 2 root 5 squared. This is going to be a multiply question, right? Because I have to multiply those together. That's 2 times the square root of 5. So in your calculator, you could take 2 times the square root of 5, and then you could square that, and you should get 20. So 16 plus 20 does in fact equal 36. So this is a right triangle. 1 squared plus the square root of 3 squared equals 4 squared. Well, 1 squared is 1. The square root of 3 squared is 3, and that does not equal 16. So this is a no. All right. So which of the following sets of numbers represents the lengths of the sides of a right triangle? So we're going to do the same thing again. You're just going to use the Pythagorean theorem. So set it up and see if they are Pythagorean triples. So longest sides, and see if they work. I'm not going to go through that one with you. You should pretty much have it figured out by now. So your homework, Pythagorean theorem, Algebra 1 homework, has 7 questions. And your converse of your Pythagorean theorem has 9 questions. So for a total of 16 total questions. Okay?